So good afternoon, good morning. It's good to be here. I'm Frank. I'm the tech sales leader for IBM Storage for Red Hat, OpenShift, and Cloud Pak. So my mission is to help you as a partner to basically paint the picture, but also to engage and help our clients marching on this journey, right? And then if you look at this chart, I'm going to continue on the metaphor here, which is, in addition to farming and animals, we can talk about building houses with plumbings, right? So each one of these platforms that Randy talked about, especially in the middle part, is Cloud Pak that is modernizing the middleware, the data service, the security, the AI. In addition to that, there's also other platform that is also being deployed and certified, validated on OpenShift. So these are the blue color towers, if you will, or houses. So they are DB2, SAP, SAS, right? Even high performance computing software, some of them are being used for the large banks like Spectrum Computing, also being modernized to run in this microservice mode using containers. And further to the left, we have these little greenhouse that will be deployed on the edges, right? So they can be used for inference, maybe driving a camera, or to infuse AI with API, right? On an edge device, could be an ARM server runs in the office, back alley of a McDonald's maybe one day would have that such an edge device. So all these new platform, all these shades of color, they all need the underlying plumbing. We call them plumbing because it's supplying the water to these houses, right? And also not just that, they also need to do the metering. In other words, to manage the data flow, right? To get the data where they need to be. So that's where this data service coming into play. We're representing this using the red color, which is Red Hat container native storage, and the green color, that's the IBM Spectrum storage, like Spectrum Skill or Spectrum Virtualized. I think one of the bundle that Randy just showed you effectively is this little house on the wheel, right? With the plumbing that you can engage the customer with. And then you can deploy this quickly on the edge, in the cloud, or on the enterprise, including that startup kit, right, with a flash system running OpenShift. And then ultimately, I think the goal here is to support industry workloads, to make these data service that I highlighted at the bottom, whether it's ingesting data, tiering data, using policy, synchronized data movements, between different sites to also help with data resiliency, like backup. And also sharing data using different protocol, right? Whether it's the traditional POSIX, NFS, SMB, or the new generation of protocols such as HDFS or Cloud Object Store, S3, right? We can always share this storage tank of water and plumbing to the platforms. And finally, the cataloging, right? So metering. How can we make sure the customer knows where the data are and supply the data where they need it to, right? So, and on top, you can see that in the purple or the dark layer, this is where we map the use case to this online platform. So we're not just building houses for houses, right? We have different use case, we have different sets of industry requirements. Different industry might have different requirements in terms of data gravity, data localization. For example, healthcare has a lot of health data that needs to be localized, whether it's in a hospital or possibly even in a country. The data such as genomics cannot leave, for example, a country, right? If you go to a hospital, the data cannot leave possibly the hospital premise or data center without your consensus, right? So a lot of these are industry challenges, and also we call them architecture decision point, whether it's data and AI or hybrid multi-cloud. So they drive the underlying use case and the workload patterns that we can map our platform into. Okay? So let me take you through a couple of these use cases, just highlight this journey, that it's not just about speeds and feeds and feature and functions. It's also about, can we make ourselves relevant to our customer's journey by understanding the application, their workloads, the workflow, right? And also the business value. Maybe if you can go to the next chart. So the last year is our agile launch for the storage software. And now we're calling this a unified data service. We're combining both Red Hat and IBM capability in terms of the, you can see here, we're representing them in different colors. So the red is the Red Hat, the green is IBM as a data foundation. And then we can stand up a different platform in the green, yellow, and blue color stack, right? In different data center or in the cloud. And then we can use that to support different line of business in the middle. So these are the 9 use cases we have developed or adapted last year. The list actually goes way beyond the 9. These are the top ones. But what I'll do is I'm going to highlight a couple of them that illustrate the problem of number 1, data gravity or centricity. Number 2 is the need for data service, right, to support for example, app modernization, which is probably the most common use case right now, low-hanging fruit. A lot of application moved into containers, like Randy talked about, and they need data service. These data service are no longer the traditional, here's my iSCSI drive, here's my fiber channel SAN, off you go, right? But now the developer are requesting, here's my PVC, persistent volume claim, what can you do for me, right? Can you put a container volume to support my app and my development for a modernizing or refactoring an application? And by the way, I'm doing this on a public cloud, right? Can you support that? Can you also produce a HNDR use case, like from 5 to 8? All these are about data movements, right? It's very easy to say we can build a hybrid cloud or multi-cloud, but without handling the data in the data service, whether it's fully synchronized using HA or asynchronous replication using DR, or in some cases tying up multiple cloud platform, depending on the customer's orientation for certain cloud providers, right? There might be a need to actually build these 3 sites all together. Maybe one site could be on-premise in a customer data center, while the other 2 platforms, one could be running in a public cloud provider, another one could be running another cloud provider, right? So I'll show you a couple. So the first one is, Randy, you can go to the next chart. The first use case is what we call the data and AI. Actually, it's an app modernization. That's an easy one to start with. So think about this, right? So we have a customer. It's actually telco. So we highlight that tower up there. It's called Jazz Cash. It's a new generation telco company from Pakistan. It's actually Pakistan Mobile. So they're modernizing the app digital payment, and by moving to OpenShift and adopting the Cloud Pak for integration for the API interface, and Cloud Pak for data as the sort of the data analytics part of the platform. So their requirements is to be able to deploy this on 3 different platforms, test and dev, which only involves 2 Cloud Pak, production, which it also needs to have other parts like security and multi-cloud manager, and then also some speech-to-text app from Watson AI. And further to the right, you can see they also want a HNDR for the same OpenShift cluster. Right? Now, in all these 3 implementation, the data service is internal to the OpenShift cluster. It's not external. We're not mounting a volume from a large SAN. Right? Now, the data here is what we call the container native data storage, so which is number 2. So that's provided using OpenShift container storage, mainly the red color from Red Hat. So that actually meets all the requirements to stand up the data service within the OpenShift cluster, right? There's no external storage that's needed. But when they move into production and HADR, now we need to actually put into some commercial grade, high-end storage as a backend. So we're actually using V7000 and a flash system to supply the same OpenShift container storage under the hood. We're also introducing the Spectrum Virtualize using the CSI block driver to supply the data. Right? So as you move from left to right, you can see how we can tune the service to meet the requirements. But at the same time, we can allow the platform to be stood up quickly, agilely, elastically, right? And using public cloud further to the right. So that's the first example of app modernization. The second example, the next chart, is data and AI, right? Very common use case from a customer adopting, developing data science platform. You can see here these different teams working together using what we call the workbench, Right? These workbench are almost like a desktop, but it's a collaborative environment with version control, with all the bells and whistles of GitHub, and also to be able to maintain application containers. Then they all need a backend AI grid to run the jobs, to run these deep learning AI training jobs, to develop the models, right, to do analytics. And then that is backended by a robust scale out data service or data fabric. Right? In this case, it's Spectrum Scale that supply the data IO. So we actually, one of our customers actually called this infinite throughput, because as they can scale up now these yellow workbench using OpenShift and pods and spin up not just dozens of them in the VM world, like using Randy's metaphor here, where we can have millions of chicken here, these containers running into different workbench. Some of the workbench can be on-premise. Yeah, some of them can actually run on my laptop, right? But they all backended by a robust platform that can scale out quickly to deliver the service, the data service, using the OpenShift CSI driver interface to feed the compute needs and the data needs. So the next chart talks about the third use case, which is data lake modernization. We have a lot of customer went through a journey of adopting Hadoop as the enterprise analytics and data storage. A lot of these platforms are monolithic. When I say monolithic, they're really tightly coupled, which means you have a very large pool of resource, of which the compute, the storage, the data, the application are all tightly coupled. Okay? But the new way of doing this is a decoupled way, like Randy talked about earlier. Decouple the compute, the data, the application, right? So now the application can be more easily, quickly, upgraded, modernized. In some cases, moving to some of these Hadoop stack is actually moving to OpenShift as well, right? So you can deploy them quickly, and more importantly, you can scale them out quickly. So if you want to run analytical job using thousands of containers, you can do that quickly, right? In this new architecture. So here you can see with the workbench is moving to Cloud Pak for data, and the underlying storage in the data, and this could be petabytes of data, are moving to a new data lake, right? This new data lake is our unified data service lake, which is Spectrum Scale or Cloud Object Store or Ceph. And you can see how this works, right? So once we decouple this, we can scale the application and analytics and AI quickly. Effectively, the same goal we can accomplish using Hadoop, now we can accomplish in this modern architecture. And we can, at the same time, we will bring enterprise data resiliency, global access, high performance storage, low cost. Right? The goal here is to have 4x the performance comparing to the traditional data lake and half the cost. So the math is just compelling, right? In terms of a business value and return on investment. And I think the next one is the last use case. Maybe I have one more. So this is probably the most challenging one. I call this flying without radar or map, right? So think about a customer trying to deploy all these different platforms, whether it's a research computing, stand up an AI sandbox, which is the second tower, or deploy an enterprise application, or a enterprise data catalog, right? These are actually 4 vertical platform or houses a customer trying to build, and they have lots of data under the hood, right? Whether it's in Spectrum Scale, that's number 3, or in the Red Hat Ceph, or in a Cloud Object Store, number 5. How do they know where the data are, right? So the cloud platform doesn't solve that problem. The cloud platform gives you the yellow and the blue that allow you to spin the thing, spin up a platform quickly, deploy them, right? The data is still in the tank. It is still in the storage tank, right? Without opening the lid, you can't see them. The way to handle this is not the traditional way, right? Continue to build more silos. In other words, you have now in addition to your Hadoop silo or data lake, now I'm going to create another platform I'm going to call it, Kubernetes or OpenShift. That's just going to be my new project, right? Shiny toys. So I think if we do this right, the new architecture in the unified data service will not create new silos anymore, right? Because we cannot decompose the data service, will supply the data it will provide you with a metering capability, or the maps, or the radar, right? So that's number 6. So whether you have enterprise data lake, that's number 3, or you have the new cloud object store from IBM, which is number 5, or Red Hat, which is number 4, right? We will provide you with an enterprise data catalog based on an IBM storage software called Spectrum Discover. Give you insight, knowledge, and follow them, keep up with data change, right? And then supply that knowledge or insight into the cloud platform. So now when you're doing your AI or enterprise deployment, you can find the data. You can assemble data sets. We just did a webinar this morning, encourage you to look into it. For the new version of Discover, we can actually trigger more action like data movements, right? From cloud to to on-premise or back. So this is a very compelling use case. What I call if the first 3 use cases is about data volume and gravity, this is really about the value we can bring, because we're no longer just a bunch of disk with wire sticking out, right? We're software. We're now also the insight of the data. Another metaphor I can make here is think about a library without catalog, or even worse, a library without shelving. All the books are piling on the floor, right? So IBM storage software give library the shelves where the data, which are the books, can be stored. And Spectrum Discover provides a catalog that a reader or librarian can search all the content without piling through or digging through the shelves, right? So I'm gonna end here. Hopefully these are inspiring use case for you. By the way, they are all real customer engagements. Some of them are still ongoing projects as we're working with our clients to sort of figure things out, put them into deployment. The goal here is make them real, make real impact, deliver the value to the clients to show that the new cloud way, not only we can scale and bring a lot of houses up and kitchen and chickens and to the farm, but we can solve real world problem, right? To support these different industries, different workloads. So yeah, I think that's it for me.
Yeah, awesome, Frank. Thanks very much. Great. So we've covered. Let's see, we've got farm animals, housing construction, library books. I think we've covered all the analogies. So this is perfect. Thank you very much, Frank.
Oh,
so
sure.
And just a quick editorial comment. Frank is being modest. It's not hyperbolic to say that he is one of the world's foremost experts on data services architecture for containerization. He works with our largest global clients. So he is a deep domain subject matter expert here, and we're glad to have him. So some quick takeaways from the session today, which hopefully you'll walk away with. Hybrid cloud, hybrid multi-cloud is happening now. It is the future. It is the present and the future. It is the evolving architectural standard that's being adopted pretty much by every organization, just about across almost every industry around the world. And containers are really the common language and the lingua franca of hybrid multi-cloud. So if you're thinking about moving into that environment, that almost implies containerization. Containerization is the language spoken there. It's the vehicle by which those become real. You definitely need a strong data persistence, data management, data services, and storage foundation. It is sometimes tempting. I mentioned a few different times that there are a lot of opportunities to do your own integration work, take advantage of open source projects and software and, try to do your own piecemeal assembly, which is certainly possible and companies do it. It's risky. It tends to be much more time consuming than you suspect. And it creates a lot of vulnerability for production, reliable production workloads. So our storage solutions for Red Hat OpenShift Container Platform, we believe are the best in the industry. We're probably biased since we own Red Hat, but I think our customers, and Frank has given you some examples, I think our customers by and large would agree. We've had great success with the solution in the marketplace, and we hope to continue growing the footprint and again, working with great partners like Tectrade that have the in-house expertise and domain expertise to architect these solutions on your behalf. And finally, containers are like chickens. So if you don't remember anything else, just remember that containers are like chickens. So That brings us to the end. I want to thank everyone for your attention. Much appreciated. I wasn't able to monitor the chat, the QA, so we have some time left now for questions. We can certainly open the floor up to that. I want to thank Tectrade again for inviting us to join you today. The QR code here is all my contact information. If you want to snap it, you'll have my virtual business card. But if there's any questions, we're happy to entertain them.